Supernovae are considered to be among the most luminous things in the universe and are thought to be violent explosions of huge stars or white dwarfs. Some of them can be dozens of times brighter than all 100 billion stars in the Milky Way galaxy put together. These explosions produce strong fluxes of neutrinos and gravitational waves in addition to light emission. Astrophysicists find supernovae to be of great interest since the characteristics of the explosions are tied to the specifics of processes taking place in the star's innards prior to the explosion, which are currently not fully understood. However, because the process is so fleeting, it is incredibly challenging to identify the supernova explosion itself. The progenitor, also known as the brilliant leftovers of an already exploded star, is what astrophysicists typically investigate. It would be useful to identify the indications of an imminent explosion and concentrate attention on the fading star before the explosion takes place in order to obtain a better knowledge of supernovae. The most current research is based on the finding that many star remnants are surrounded by too much dense material to fit into the most popular theoretical models of supernovae. The scientists made the decision to test earlier theories put forth by other groups that this matter was created not by the explosion itself, but rather as a result of events within the star that caused it. Additionally, they proposed that these processes might exhibit some visible characteristics that could serve as signs before a supernova explosion. The astronomers ran computer simulations of the events taking place in the star's outer layer, known as the envelope, which forms when it is poised to explode, in order to confirm the accuracy of this theory. They proposed that matter emerges from this layer when energy is fed into it from below, as is typically the case with dying stars. This process has detectable signs that astronomers may examine. The star's computer model approximately matched a real red supergiant star whose interior dynamics were explored numerically. This type of star has the biggest known radius, which is several hundred times that of the Sun. Its surface temperature is around 4,000 K, which is about 2/3 of the Sun's temperature. Betelgeuse, a well-known star that will likely undergo a supernova explosion soon, is one of the most well-known members of this class. The simulations confirmed that the researchers' hunch that the stuff from the envelope explodes from this layer and produces electromagnetic radiation was accurate. This pre-explosion radiation may linger for hundreds of days prior to the star exploding, according to the model, and it is strong enough to be seen by upcoming infrared telescopes. Additionally, the radiation spectrum and duration both have quite distinct characteristics that should make it possible to distinguish the radiation of a future supernova from that of other space-based light sources. If the scientists' numerical analysis is accurate, and supernova explosions are indeed preceded by observable radiation with a specific spectrum, finding this radiation will allow light, neutrino, and gravitational observations to be coordinated before the explosion occurs in order to study it thoroughly. Hopefully, this will significantly increase our understanding of the evolution and structure of stars.